So up to now, yesterday we did about units. The units are the basis of measurements. If we want to measure any physical quantities, so to measure any physical quantity, we should have some basis. So those standards or basis which we consider, they are called as the units. Then we discussed about the physical quantities. So Vedika, what are physical quantities? Vedika, what are physical
Physical
quantities?
quantities are the measurable quantities which can be measured.
Yeah, the measurable quantities, they are called as physical quantities. And how many fundamental quantities are there?
There's seven.
Seven.
Hmm?
Seven physical quantities.
There, no, not physical. There are seven fundamental quantities.
Yes.
There are seven fundamental physical quantities. Today we'll be doing dimensions. Yesterday we did about derived units, right? And also their conversion from one unit to another. Today we'll be doing the dimensions. So dimension means expressing the derived quantity. So expressing the derived quantities in terms of physical quantities. Hmm. Hmm. In terms of fundamental physical quantities. So we also call it at MLTs. Generally, we call them as MLTs or dimensions of any physical quantity. So let us see how we express them in terms of the dimensions. So for expressing them in terms of dimensions, we generally use their short forms. For example, for mass, we use M. For length, we use L. For time, we use T. So these are called MLTs. Then apart from them, the others like we study for temperature. So for temperature, we use Kelvin. So these are not the units. These are just the short form of the physical quantities. So we write them as mass, length, time. Kelvin is for temperature. So K symbol, we write K whenever we are talking of temperature. Then we write MOL, mole, when we are talking of amount of substance, that is mole or molarity. We'll be writing ampere for current. Okay. And candela for CD for candela. So these are general short forms also. As you can see, up to now mass, length and time for MLT, we have not used the units. Whereas for the others, we are using the units as the symbols. Okay. So how it works? Let us see. Suppose I want to find out the dimensions of speed. So simply the speed is defined as distance per unit time. We can define speed as distance per unit time. So distance is a dimension of length. Distance will be measured as length. So we write it as L, time as T. So we can write speed as L T minus 1. So T here is power 1, power plus 1. When goes to the numerator, it becomes LT minus 1. So the dimensions of speed would be LT minus 1. And all this dimensional formula will be expressed in terms of or in square brackets. So we will be writing the dimensional formula in square brackets. Okay. So in the similar way, can you tell me what will be the dimensions for acceleration?
LT minus 2.
LT minus 2. Since acceleration we write as change of velocity delta V over T, which we can write as V minus U over T. So V and U, they have the dimensions LT minus 1. So LT minus 1 divided by T will give you the dimensions of LT minus 2. Okay. So just once you joined a little bit late. So up to now we had discussed about dimensions. Okay. So dimensions mean expressing the derived quantity in terms of fundamental physical quantity. So we have to express whatever derived quantity is given in terms of the fundamental quantities. So here we will be writing, these are the symbols that we will be using for different quantities. So in the same way, can you try out to obtain the, can you try to obtain the dimensions of force, momentum? Try to obtain the dimensions of force, momentum, work, energy. Okay. So can you obtain these dimensions? Force, momentum, work, and energy. Also, I want a gravitational constant, G. So to obtain their dimensional formula, we need to have their formula first. So the formula of force is given by, we know that force is given by mass times acceleration. So Pritam, uh, can you tell the dimensional formula of force?
Hmm.
Use your
Acceleration,
notebook. Yes.
like acceleration will be LT minus 2 over
Yeah, acceleration is lt minus 2, which we just found out. And
and mass will
mass will be denoted by cap symbol m. See,
M
we have written here. We just
MLT minus 2
yeah, so the dimensions will be mlt minus 2 and they will
2
be enclosed in square
bracket.
brackets. Okay. So similarly, quickly find out the dimensions of momentum and work also. Find out that everyone find out the dimensions of momentum, work, and energy.
So can you tell the formula of momentum?
Yeah, the formula of momentum, I think you should be remembering this. Momentum is given by the formula mv. Work
So
done or work is given by force times displacement. Energy is given, you can either take potential energy or kinetic energy. So potential energy is given by the formula mgh. Kinetic energy is given by the formula 1 over 2 mv squared. Okay, so who has got the dimensions of momentum?
Sorry, ml by t.
Yes, it is ml
MLT minus 1.
mlt minus 1. Then dimensional formula of work,
ML2 T minus 2.
it would be ml2t minus 2. So I think Vedika has understood how to obtain the dimensional formula. So similarly, the dimensional formula of a potential energy will also be ml2 t minus 2. For kinetic energy also it would be ml2 minus 2. So why I can say this, that work and energy, they are equivalent. If you, even if you try to find out, so just try to find out. All these constants, they are not taken. They are just numbers. Since these numbers, they do not have any units, they do not have any dimensions. So that is why we do not consider them. Okay. So you just consider the dimensions of these quantities. Now we want to find out the dimensions of gravitational constant. See, so for this we need to write down the formula of gravity. So F is given by G m1 m2 over r square. So to find out for G, we need to transpose everything to the other side. and therefore we'll be getting the formula to be G equals F R squared over M1 M2. Right? Now, as we can see, we already know the dimensions of force. So we should put here the dimensions of force, which is MLT minus 2. R is a type of length. So it would be written as L and it's a square. So it would be 2 divided by M1 is in kilograms. So it is mass. M2 is also mass. So again, we will write here M to the power 2. Okay. So finally, we get the dimensions here. We can write the dimensions as M minus 1, L3, and T minus 2. Right? So these are the dimensions of gravitational constant G. Okay. So similarly, can you find out some others if I give you the formula? Can you find out the dimensions of some other physical quantity?
Yes, sir.
Okay. So try doing them. I'll provide the formula for you once, and then try to find out their units. Okay. So you have here angular momentum. Angular momentum denoted by the symbol L, and it is equal to mvr. You have torque given by R cross P. So have velocity gradient. So these are the terms which you have not heard, but since I have provided the formula, so you should try to write. So velocity gradient, it's given by dv by dx. Then for force, for charge, write the dimensions of charge, Q. Electric potential, V. So we will try one by one. Electric potential denoted by the symbol V. So as you have studied in class 10, can you tell the formula of electric potential? Does anyone remember the formula of electric
Into R.
potential? No, it's not 2R. Electric
I
potential is
IR.
W over Q. Work done per unit charge. Okay. Now, to find out charge, we should use the definition of current. So, current is given by I equals to Q by T, and hence charge would be given by I multiply T. Okay. So, okay, I'll let you write down. Try to write down. I'm giving you 2 minutes. Okay. So, in 2 minutes, try to write down.
So what did you write for that second one of triangular momentum?
Angular momentum. It's MVR.
The
R
down
cross
down.
P. Yeah.
After that,
After that, it's torque, R cross P, where R stands for distance and P is the momentum. Sorry, R cross F. It's not R cross P. It's R cross F, where F is the force.
okay,
So you
sir.
can take it to be R multiply F. Okay. So I think you have done 1 more minute.
I got the first three.
You got the first three. Okay. Okay, very good. Still some time remaining. So can attempt the next two. Okay. So just check it. Those who have done, they should check it. The first one you should to t minus 1. For this, you will be getting ml2 t minus 2. For this, you should be getting m0 lt minus m0 t minus 1, m0 l0 t minus 1. For this, for charge, you should be getting at.
-1.
No, there is no minus 1.
Yeah.
Okay. For electric potential, see, for electric potential, you'll get here work done is represented by the dimensions m, l, 2, t minus 2. So currently you are not able to remember, but you can recall it. Okay. You can go just one step to perform the dimensions of work by the formula force multiplied displacement. Okay. So you can go back. See, it is in my habit, I remember all of them. But if you do not remember, the dimensions of work. So possible, I think it's not possible for you to remember it right now. Okay. So if I ask you what are the dimensions of work, so maybe you have forgot. So just go a little back like this. Write down for work. We can write force multiplied displacement. Force can be written as m into a. So work will be MAS. Okay. So in this way, we find out for work, which will be M LT minus 2 and L. And finding out, you will be getting M L2 T minus 2 for work. Okay. Divided by charge. So charge is represented by AT. Okay. So can we write the dimensions?
Yes, sir.
Yeah. So what should be the dimensions?
ml2 at minus 3.
Yeah. ML to A minus 1
T
and
minus 3.
T minus 3. Right. So these are the dimensions of electric potential. Okay. So now can I give you one more? Will you try out? Okay, try out. And now I will not give the formula. You know the formula and try to do that. What should be the dimensions of resistance?
Yes, sir.
Okay, try doing this. Find out the dimensions of resistance.
Sir, VA minus 1.
VA. But V is not a fundamental quantity. We express V in some other terms, right? You have to express it in
Okay.
okay. So use that. Use your time. Take your time for again. Take your time for 2 minutes. Again 2 minutes.
Sir, done.
Done. Vedika, what about you?
ml2 a minus 2 t minus 3.
Okay. Vedika, just one.
I got
Yes, sir.
ML E minus 3 and I.
Okay. We instead of I we use A. Okay. We use this symbol A.
Okay.
Okay. Just one. Just one. Are you there?
Yes, sir.
Okay, so are you getting?
Yes, sir.
So see, first of all, we will write the formula for resistance. The formula for resistance R is given by V by I. Okay, where V is electric potential. The dimensions of electric potential we have calculated here. We have found out here. Or you can do it again. If you want, you can do it again. So V is equal to W by Q. You can use this relationship and obtain the dimensions of V. Okay. Or if you just refer previous notes, you have got here dimensions of electric potential as ML2 A minus T minus. Okay. So we'll write here for V M L2 T minus 3 A minus 1 divided by current, which is again A. So you will be getting the dimensions.
M.
ML2T minus 3 A minus 2 as the dimensions of resistance. Okay, so I expect that you can find out some of the dimensions. You have understood?
Yes, sir.
Yeah, yeah. Anyone facing any issue? Okay, so find out dimensions is and okay. So Preetham has understood. Just want what about you?
Yes, sir. I got it.
Okay, so find out dimensions of uh, coefficient of viscosity. So I'm giving you the formula and you have to find the dimensions of coefficient of viscosity. So the formula for is F equals eta A dV by dx. Okay. So I think you are familiar with almost all the terms. See here, only thing you do not know is eta. Here eta is the coefficient of viscosity and A is the area of cross section. Okay. Also, dV by dx is the velocity gradient which we have calculated earlier. So you can take 3 minutes for this. You have to find out the dimensions of this physical quantity eta, which we call coefficient of viscosity. Then you have another one. You have to find the dimensions of coefficient of viscosity. Then you have to find out the dimensions of resistivity also. So first of all, find out this dimensions of coefficient of viscosity. If you need any help, just tell. Okay. So anyone who has got? So using this formula, F equals eta A dV by dx. Okay. So if any help is required, you can tell. We first transpose the terms to find out the formula of eta. So you will be getting F multiply dx by dv. F multiply dx by dv over A will be equal to eta. Okay. So now just put out all the dimensions. At the place of F, write the dimensions of F. At the place of A, write the dimensions of area. dx is the dimension of length, dv is the dimension of velocity. Okay. So who has got answer?
I got ml minus 1.
ml minus 1. Okay. So I'm just keeping your answer over here, ml minus 1.
So ml
Okay.
minus 1, t minus 1.
Okay, you are getting ml minus 1, t minus 1. Let's have a look. Okay. Anyone else who is left now? Pritam?
Sir, ml minus 1, t minus 2.
ml minus 1, t minus 2 you are getting. Okay. So let's check it out. So putting the dimension of f, we get here ml t minus 2. Yes, this is the dimension of source. For dx, we write the dimension L and dv is Lt minus 1. Okay. Divided by area, which is L squared. So you get here, you get m. For power of L, you get here 1 plus 1, 2, minus 1 and minus 2. So 2 minus 3. 2 minus 3 makes it L to the power minus 1. Then for t, we get the power t to the power minus 1. Sorry, minus 3. Minus 1 plus it's minus 1. T we get the power minus 1. So this is the correct answer. The second one. Okay. So second answer was just one's answer. So you got it correct. It's ml minus 1, t minus 1. Now others can try out to find out the dimensions of resistivity. How can we find out the dimensions of resistivity? Which formula to be used? Yes, which formula should we use to find out the dimensions of resistivity?
R is equal to rho L by A.
Okay, we will be using R is equals to rho L by A. And first we'll find out the dimensions of R, then we'll find out the dimensions of. Okay, so use that. Use that and solve it before me. R equals rho L by A. You have to find for rho, right? R A over L. This is your rho. Find out the dimensions of R, which is R equals to V by I. So for V, we should use the dimensions of the V, which we have learned earlier. Okay. So V is given by W by Q. So you can take total of 3 minutes for this.
Sir, done.
Done. Very good. Within a minute. Okay.
Yes, sir, done.
Yeah. Okay. So what is the final answer you have got?
ml3 t minus 3 I minus 2 or A minus 2.
Okay. So
Same.
let me write your answer here. So Pritam, what's your answer?
The same answer.
Yeah, same. Okay. So I think then you are correct. I should not be checking it out. Just one, what's your answer?
Sir, ml 3 minus t minus minus.
Okay.
I'll
Very
do it
good.
again.
Okay, okay. So very good. See, you can try if you can try it out. Now I think all of you know how to find out the dimensions. Okay. Now one of the very important use of there are very important uses of dimensions. First of all, dimensions can be used to verify the formula. They can be used to check whether a given formula is correct or not. Okay, so if you know the if sometimes you have the formula and you want to check whether it is correct or not. Okay, so we use dimensions over there to find out whether the formula is correct or not. Okay, so let's see, for example, let's try out this one. So we know the time period of a simple pendulum. Time period of simple pendulum is given by the formula 2 pi under root L by G. Okay. So this is the famous formula given for the time period of simple pendulum. We want to check out whether the given formula is correct or not. So see, we can write down the formula. We have the formula over here. Now to verify, we will see the dimensions of the left hand side. Okay, and if the formula is correct, so it has to be dimensionally also correct. It should not be on the left hand side you are getting some other unit and on the right hand side you are getting some other unit. So the formula has to be dimensionally correct. So on the left hand side, you have only one physical quantity, that is time. So the formula has to be dimensionally correct. It has to be LHS is just M0 L0 T. Are you getting? This should be the dimensions of LHS. Okay. Now let's try to find out the dimensions of the RHS problem. So on the right hand side, this 2 pi is dimensionless. It does not have any dimensions. The dimensions only belong to length and G. Okay. So it is on the RHS, you will find the dimensions of length. So it is under root of L over G. So we will have under root of dimensions of length would be L divided by the dimensions of G. And
Gravity
G is
constant.
acceleration.
Hmm.
Right? It is acceleration due to gravity.
Yes, sir.
So we can use the dimension of acceleration as LT minus
T
2.
minus 2. Yes, sir.
So these L and L cancel and you have your under root of
1
1
by
by
T
T
minus
minus
T. Yes, sir.
T minus 2 goes to the numerator, becomes T plus 2,
T2.
or you can, okay, or you can use this T to the power 2 whole power 1 by 2. Under root means power 1 by 2, and hence you get the dimension as T, which we can write as M0 L0
0
T.
T2. T, yeah.
T. Right?
Yes, sir.
So we observe here that the LHS and RHS both are same.
Yes, sir.
Okay. So we will say that the formula is dimensionally correct. LHS is equal to RHS. Now,
Yes,
what
sir.
should be the dimensions of theta?
So,
Yeah, dimensions of angle theta.
Saying length.
Okay, do you remember yesterday we did the formula for theta?
yes, sir.
Yeah. So what was the formula?
Area by R square.
No, it's length by r.
Length by
Length of arc by radius.
Hmm.
Okay. So what could be its dimensions?
1 minute. Theta is L by R. L.
Okay, L is a length. Okay, L is length, so it should have dimensions of length. R is radius, so it should also have the dimension of length.
Length 1.
So it should not, it should have the dimensions as L0.
Yes, sir.
So we can write it as M0 L0, T0. So it should not have any dimensions. So theta is a dimensionless quantity. You should keep in mind that theta is dimensionless. It does not have any dimension.
Okay, sir.
Okay. Now verify this formula. Verify this formula. Verify the formula. F equals 6 pi eta RV. Now, what are the different things? What are the different terms? I explain all of them to you. So, of course, you know about F. F stands for force. 6 pi is a constant. Eta is coefficient of viscosity, which we discussed. Eta is coefficient of viscosity. R stands for radius. And V for velocity. So check whether the given formula is dimensionally correct or not. Okay. If you want any help, we have here already calculated the dimensions of eta. You can have you noted down the dimensions of eta? It's ml minus 1 t minus 1.
Yes, sir.
Okay. So you can see here we have the dimensions of eta. You just need to verify this formula. F equals 6 pi eta RV. Is this formula correct or incorrect?
So what is the last thing? 6 pi NR?
Eta. That's the eta
Okay, 6 pi
coefficient of
eta,
viscosity.
6 pi eta R. What is the next thing?
V means velocity.
Yes, sir. It's correct, sir.
Correct?
Yes, sir.
So this formula is correct. Okay. F equals to 6 pi eta RV is correct formula. So okay students, today we have studied about the dimensions, and today also you will be getting one test. So you have already one test active. How many of you have attempted the test?
Sir, me.
Vedika and Jaswant, please attempt the test. That's okay. Jaswant attempted.
Yes, sir.
Okay. So I'll check and I'll be posting the scores at 8 p.m. Before 8 p.m.